All right, so here, if we are expected to state the hypothesis for MVT and rolls, and part of the hypothesis is that the function would be differentiable on the open interval. Sometimes when you take a look at this function and the interval that's given, it may not be differentiable. For example, you could have a vertical asymptote within that interval. So then the function's not differentiable there, right? Because there's a break in the graph, or a cusp, or a sharp point. So that's why it's important that you take a look at the function, you take a look at the interval, and also you know what the graph looks like. Okay, so if I look at this graph right here, first of all, this is an absolute value graph. If I rewrite this in standard form, it's the opposite of the absolute value of x minus 3 plus 3. Describe this graph for me, please. Somebody. But you should be able to do the, I know it's a V-shaped graph, there's a cusp, I'm fully aware, but you should be able to sketch this graph without a calculator. Yeah. Shifts, right 3, up 3. It's a reflection. Oh, reflecto? Okay. Sure, I'll take it. So if I sketch this graph, you told me right 3 and up 3, and the graph, there you go. Okay, everybody good? You have a visual. Is it perfect? No. Is it good enough? Yes.
That looks pretty perfect.
Okay, okay. So I am looking, so if I said here, it says verify the hypothesis of Rolle's theorem, so we would have to state the hypothesis. First of all, the first part is the function continuous on the given interval? Yeah, it's continuous. I could sketch this without picking up my pencil. That's not how I would give my reason, but the function is continuous. The second part is what? Differentiable from 0 to 6. Is this function differentiable from 0? Why? Because of the cusp. Now, if we said, I don't know, I'm just making this up, but like -5 to 2. Yes. I don't know, 5 to 10. Yes, but it's because of where that vertex is. So we would have to state that Rolle's theorem cannot be applied as f of x must be differentiable over the open interval from 0 to 6, and f of x is not differentiable where?
3.
Yep. More specifically, you would just say x equals. Okay? At x equals 3. Okay, so you need to state, first of all, which portion of the hypothesis is negated by this issue. Okay, questions? Okay, so does it happen? Yeah, that's why, remember in that first problem, if I just looked at the function, it was not continuous because of the vertical asymptote at x equals 0. But then we looked at the interval, it was from 1 to 4, so 0 wasn't even included, so it was a non-issue. Okay, but you have to look at it. Questions on this one before we move to the last one, which is the application, like real life. Okay, velocity interpretation of the mean value theorem. So, yeah, this is great when you are given a calculus problem, but what you want to look at is, can this ever be applied in real life? So, what the MVT would imply is that at least once during some time interval, the instantaneous velocity must equal the average velocity. Okay, so it would be the movement of something. The movement of a person, the movement of a car, particle, whatever. Okay, and a lot of times you're going to be tasked with using this for some type of velocity in a car. So here we have Steve, who is driving on I-95 from Springfield to Savannah to visit his grandmother. And at 2 p.m. he is at milepost 110. Okay, so at 2 p.m. he's at milepost 110, and at 5 p.m. he's at milepost 290. Assuming that the posted speed is 55. This is posted. This is not what everybody else around you is doing. There's a difference. Okay? Is there enough evidence that to prove that Steve is guilty of speeding sometime during his trip. So one thing I want to point out is, regardless of what we all do, is going 56 miles per hour, is that considered speeding?
No. In the law, yes.
In the law, yes it is. So if I can prove that Steve at some point was doing 56, he was speeding at some point. Agree or disagree?
Agree.
Okay, so the first thing we want to look at is our hypothesis. Yeah, we just need to prove it. I mean, you could say, yeah, of course he's speeding, but you need to prove it. You need something numerical. Okay? Are you going to throw your friend Steve under the bus? Probably not, but that's not the point. So what we're saying is that Steve's position is continuous. You don't have to write Steve. Continuous from 2 to 5. He did not need to get off and go to the rest stop or whatever. He was fine. He was good to go. So that's the first part. In the second part, okay, here's my quick question. Even though it says MVT, why can't this be rolls? What is the second part of rolls? But also, too, wouldn't it be equal to 0? Obviously, he's getting somewhere, right? Okay, and the y values are not the same. So that's true. So even if it didn't say anything, so here I only need 2 portions for my hypothesis. I don't need the third part because I already have my y values. So then we would say, since his position was on 95 and continuous, the position, meaning S of t, is differentiable on the open interval from 2 to 5. So really, this is we're just proving that he went over 55. We're not talking about giving him a ticket. We're not talking about handcuffing him and throwing him in the back of a paddy wagon, like nothing like that. We're just saying, did he drive in excess of 55 miles per hour? I'm not the speed police, please. All right, so in our conclusion, we have S of 2, which at 2 o'clock, he was at mile marker 110. At 5 o'clock, he was at mile marker 290. So when we're looking at the velocity or the average velocity, this is, when we're talking about average velocity, it is the slope of the secant line. Okay? So we're basically saying S of 5 minus S of 2 over 5 minus 2. So S of 5 is 290 minus 110 over 3. So what is that, 180? So this is 60. So the average velocity was 60 miles per hour. Okay? Can I find F prime? I don't have a function, right? But this is enough. So here, if we're using MVT, all we have to say is the average velocity as calculated by way of the MVT, I just wrote via, okay, was 60 miles per hour. Therefore, Steve was speeding at some point between 2 p.m. and 5 p.m. Otherwise, his average speed would not be 60. Agree? Okay. Questions? Okay.